In this video, we're going to explore solving inequalities. And really, we're talking about two different types. The first type we're going to look at is an inequality where we just have one variable that we want to isolate. The second type is one where we have multiple variables, usually two, where we want to isolate one variable on one side of the inequality, everything else kind of by it on the other side. We're also going to take a look at trying to figure out if points are actually part of the solution set to an inequality. So the first type of inequality that we've got are ones that are just one variable. Now, in solving these, in a lot of ways, we're going to solve these just like we do an equation. Our goal is to get that variable by itself and everything else moved over to the other side. So when we had an equation like 2y minus 7 equals 11, we would solve by adding 7 and then divide by 2. Again, our ultimate goal to get y by itself on one side, and then everything else gets over to the other. So we would solve that, we'd get y equals 9. Inequality is not very different. It's just there's a couple minor things that we want to be careful of. One is we want to make sure that the variable is on the left-hand side. It just makes it easier when we get to the multivariable inequalities if we have that habit of bringing the variable over to the left-hand side. It's not going to really confuse us as much as if we're kind of loose with what side we want to put the variable on. So looking at 1b, the inequality below 2y minus 7 equals, or sorry, less than 11. It's kind of the same as the equation. We already have that variable on the left-hand side, which is good news for us. So it's now just a matter of moving that 7 over to the other side of the inequality. Again, this inequality kind of divides it for us. So we've got 2y is less than 18, and then we're going to divide by 2 to get y is less than, oh, I got to do a better job of drawing my less than sign. All right, less than 9. So that's the inequality solved. Now, it doesn't say to graph it, so we're not going to. If we wanted to, we could put that 9 in the number line. Because it's less than, we would have an open circle, and then that would shade over to the left. For 2b, same idea, except there's something that's it's a very important idea when we're solving inequalities, that in some cases we have a negative coefficient on the variable. And so we have to know what are we supposed to do with that. So let's just kind of go through step by step, though. First thing we want to do is reverse by subtracting 5. And we've identified that the variable is already on the left-hand side, which is good news for us. So we've got negative 3y is greater than negative 12. And then we're going to divide both sides by negative 3. And here's where that little rule comes in, that if we're dividing or multiplying, but usually dividing, by a negative number, we have to flip the inequality around. So instead of y is greater than 4, we're going to now have y is less than 4. So again, whenever dividing by a negative number, that inequality's got to flip around. All right. And 3b, we could, if we wanted to, distribute, but it makes things a lot more challenging to do so, in my opinion. Although that's not an incredibly terrible one. Instead, we probably want to go through the process of reversing operations. So first take away 2 from both sides. Giving us negative 3 times the quantity y plus 4 is less than or equal to 9. Then at that point, I'm going to divide both sides by negative 3. And I'll have y plus 4. And again, because I'm dividing by a negative number, the inequality has to switch around. So instead of less than or equal to, it's now greater than or equal to negative 3. And then to finish it off, I've got to subtract 4 from both sides of the inequality, giving me y is greater than or equal to negative 7. And there's my solution. So those are all worked out, ready to go. So that's what we're dealing with when we have inequalities with one variable. Again, very much like solving equations, just make sure your variable is on the left. And if you're dividing by a negative number, that inequality's got to be flipped. And I've said it like 4 times because it's that important. So what happens then when we have multiple variables? We have inequalities where we have an x and a y. What do we do there? And actually, let's get a completely new set of problems. Here we go. So for these, we've got 3x plus 2y is less than 6 for number 4. For number 5, we've got 7x minus 4y is less than or equal to 56. And for number 6, we've got negative 2x minus 5y is greater than 50. Let's tackle number 4 first, and then we'll do number 5, because there's something kind of unique about that one. So in this case, we're solving the inequalities for y. So we want to isolate y, which means that everything else is going to have to go to the other side. And so to do that, I have to move the 3x over first because it's not really attached to the y. It's just kind of floating there on the end. So I'm going to subtract 3x because this is currently, even though it's not written, it's essentially adding 3x. So we're going to subtract 3x from both sides. And I'm going to have this 2y is less than. Now, we have options on how we can write this, but one thing we want to make sure of is we don't accidentally combine like terms that are not like terms. So when we have a 6 and a negative 3x, those are not like terms because the 6 does not have a variable attached to it. So we can't put those together. But I do have a choice. I can do one of two things. I can write it as this right-hand side as 6 minus 3x, or I can write it like this, negative 3x plus 6. And just thinking ahead of the next sections that we're going to cover, the reason I want to put it in that form is it's in the kind of the modified slope-intercept form, the y equals mx plus b. It makes it a little bit easier for me to identify graphs quickly. So then I'm going to take that number in front of y, which is a 2, and I'm going to divide through. Now, keep in mind that, yes, I'm dividing negative 3 by a number, so I've got a negative divided by something, but I'm not going to flip the inequality around because I'm not dividing by a negative number. So there's a big difference there. And then, oops, almost lost my x there. 6 divided by 2 gives me 3. So that's my inequality solved for y. Now again, we want to keep y on the left-hand side because that's the one that we're looking to isolate. On number 5, what I like about this problem is there's a couple places where we can make some significant mistakes. One of them is the sign on 7x. 7x is positive. Yeah, there's a negative right after that, but that's attached with the 4y. The other thing too is if we try and move that 4y over, for an equation, that's not a big deal. And honestly, if I was trying to solve the equation, I probably would move the 4y over to the right-hand side. But because we've got an inequality, we're going to try and keep everything on the left-hand side for the purposes of graphing later. So I'm actually going to leave that 4y exactly where it is and deal with the aftermath of that. So I've got a 7x, so I've got to take that away from both sides. And again, I'm going to put that x in front of the 56 to keep it in that modified slope-intercept form. And then because I've got a negative 4y, I'm going to trying to solve for y, I'm going to divide by negative 4. So again, dividing by a negative number, that inequality's got to flip around. So instead of y less than or equal to, it's now greater than or equal to 7 over 4 x. And then 56 divided by negative 4 is negative 14. So those are a couple examples of how do we deal with problems where we've got multiple variables and we want to isolate one. Not a whole lot of differences between when we did it with linear equations. With the inequality, we want to make sure that that variable that we want to isolate is on the left-hand side. So then the last part is, well, we've got these inequalities all set up ready to go, and eventually we're going to have to look at them from a graph and try and figure out, are these points solutions or not? In order to do that, we're going to have to figure out, well, how do we actually make sure it's a solution using just the points and not necessarily using the graph? So we've got points here, 3, 2, 2, negative 5, and negative 3, 4. And we want to see if they're part of the solution set, the 3x minus 2y less than or equal to 12. What it means to be part of the solution set is that if we were to take those numbers and substitute them in, we would be left with a true statement. And the only way to do that is to actually take those numbers and plop them in for x and y. So we've got an ordered pair x comma y. I can take that 3 and that replaces any x's I see. So my new inequality is going to look something like this. So I'm going to do this, well, should be good on this. 3 times 3, and then minus 2, and then the y coordinate is 2. And I'm not going to do anything with the right-hand side because it's already just a number, which is what I'm looking for. So what I'm going to take next then is take 3 times 3, which is 9, and then 2 times 2 is 4, and 9 minus 4 gives me 5. And so I want to evaluate what's left. If this is a true statement, then it is part of the solution. So 5 less than or equal to 12, totally. So yes, that is part of the solution to the inequality. I do the same thing with number 8. Take x and plug it in as a 2, and take y and plug it in as a -5. So 3 times 2 is 6. -2 times -5 is +10. And so we've got 16 is less than or equal to 12. That is a big no. Not a true statement. And finally, the last one here, we're going to plug in -3 for x and 4 for y. And so we've got -9 minus 8. And I think I already know the answer on this one. -17 less than or equal to 12. Absolutely, a negative will always be less than a positive number. So just again, to recap, we've looked at solving inequalities where there's just one variable. We looked at solving inequalities where we had multiple variables and we wanted to isolate one. And we also looked at taking points and determining if they're a solution to the inequality.